In this video, let's solve problems involving geometric applications of the distance formula in 3D. Alright, here's the first one. Show that the points P, Q and R are vertices of a right angle triangle. The points are P minus 347, Q minus 433 and R minus 763. Pause the video, think about it. How will we prove that these 3 points are vertices of a right angle triangle? Okay, let's plot these points first. First one is P minus 3, 4 and 7. So this is P minus 3 along the x-axis, 4 along the y-axis and then 7 along the z-axis. So this is P. Then we have Q minus 4, 3, 3. So minus 4 comma 3 and then 3 units along the z-axis. So minus 4, 3, 3. Third one is minus 7, 6, 3. So minus 7 and then 6 along the y-axis and then 3 along the z-axis. All 3 points are in, let's see, first and second octant. These are the points. Now, do they form a right angle triangle? Can we visually see that? Let's join the sides. If we join this side, this seems like the hypotenuse. And let's see. Well, it sure looks like a right angle triangle, but we can't be 100% sure. How can we be 100% sure that this is a right angle triangle? Think about it. Alright, so what are the properties that a right angle triangle has that we can use to our benefit, to our advantage? One thing that comes to mind is the lengths of these sides. For every right angle triangle, the perpendicular and the base when squared add up to the hypotenuse. Hypotenuse square is equal to the perpendicular square plus base square. If we can figure out the length of the sides, we can figure out whether the triangle is right angled or not. So let's do that. Okay, this is our triangle. Let's put it here. Okay. So what are these lengths? These are D1, D2 and D3. Let's find them. Let's pair them up. Let's first find PQ. PQ using the distance formula, the difference is minus 1. That squared is 1. 4 and 3, the difference is 1. 1 square is 1. 3 and 7, the difference is 4. So 4 square is 16. 16 plus 1, that's 18. So D1 is root 18. This purple length is root 18. Let's find the other two. We have D2, that's QR square. Minus 4 minus 7. The difference between minus 4 and minus 7, that's 3. 3 square is 9. 6 and 3 are 3 units apart. So that's also 9. 3 and 3 are same. So that's 0. 9 plus 9, 18. Again, this is also root 18. So this white length is also root 18. Let's find the green length, D3. That's PR. So minus 3 and minus 7 are 4 units apart. So that's 16. 6 and 4 are 2 units apart. That's 4. 3 and 7 are 4 units apart. So 4 square is 16. 16 plus 16 is 32 plus 4 is 36. So this becomes root 36. And let's see if this follows Pythagoras theorem. D1 square plus D2 square, that's 18 plus 18. That's actually D2 square, that's 36. So yes, Pythagoras theorem holds true in this triangle, which means this triangle is definitely a right angle triangle. But using some math, we now are 100% sure that this triangle is indeed a right angle triangle. Let's solve one more. Let me get rid of this. Okay. Show that the points P, Q, R and T are vertices of a parallelogram. Now pause the video, try this on your own. Alright, now before we plot the points, let's discuss what properties can we use that will help us figure out whether these points form a parallelogram or not. What does a parallelogram do? Let's think about the sides and length of those sides. So the clue here is a parallelogram has the opposite sides parallel and equal. So if we can prove that the opposite sides are equal in length, we can say that this is actually a parallelogram. If that's not the case, then this will not be a parallelogram. So what we need to do is find the lengths of the opposite sides. Now let's plot the points. The first one is P minus 1, 2, 1. So this is P. Then we have Q, 1 minus 2, 5. Then we have r, 4 minus 7 and 8. And then we have t, 2 minus 3 and 4. Okay, these are our points. Now, visually, this does seem like a parallelogram. Let's join the sides. 1, 2, 3, and 4. Let's see. Does this look like a parallelogram? Are the blue lengths equal to each other? Are the purple lengths equal to each other? For that, we have to use some math. We have to use the distance formula. Pause the video and try this on your own. Okay, let's do that. Let's put our figure here. We have D1, D2, D3, and D4. D1 is between P and Q, so let's find that first. PQ is equal to square root of minus 1 and 1. They're 2 units apart, so that's 2 squared 4. 2 and minus 2, that's 4 units, so 4 squared is 16. 1 and 5 is 4 units, that's also 16. So 16 plus 16 is 32, plus 4 is 36. So D1 is root 36. Let's find the other sides. D2, that's QR. Q and R. 1 and 4, that's 3. Minus 7 and minus 2, that's 5. And then 8 and 5 is 3. Squaring all of them. So 3 square is 9, 5 square is 25, and 3 square again is 9. So 25 plus 18, that's 43. So D2 is root 43. Now let's find the other two sides. They better be equal to root 36 and root 43 if we want this figure to be a parallelogram. The next one is D3. That's going to be RT. So R and T, X coordinates are 2 units apart. 4 and 2, that's 4. Minus 7 and minus 3, that's 4 units apart. 4 square is 16. 8 and 4 are 4 units apart. So that's also 16. 16 plus 16 is 32, plus 4, 36. That's exactly what we want. So D1 and D3 are equal. These blue lengths are actually equal. Let's figure out this last length. That's going to be PT or TP. So 2 and minus 1, that's 3 units. 3 square is 9. Minus 2 and 3, that's 5 units. 5 square is 25. And then 4 and 1, that's 3 units. That's also 9. We've actually calculated this before. 25 plus 9 and 9, that's 43. So D4 is equal to root 43. So yes, D1 and D3 are equal, and D2 and D4 are also equal. So the opposite lengths are equal. This means that this is definitely a parallelogram.